Okay, so this is chapter 2, section 2. This is video part 2 of what we're talking about, polynomial functions of higher degrees. So here we're going to talk about multiplicity of x-intercepts. If a root occurs more than once, then the multiplicity is the number of times a root occurs. So remember, root is the synonymous with solutions, x-intercepts, zeros. If our solutions for the x-intercepts are occurring more than once, or even once, however many times that solution occurs, we're talking about its multiplicity. How many times does that root occur? If it occurs an even amount of times, so like 2, 4, 6, 8, etc., then when we're graphing it, the behavior that occurs at that zero is we're going to touch and turn at that point. If that solution, when we solve, it occurs an odd number of times, so 1, 3, 5, etc., we're going to cross through that point. Alright, so in order to understand the concept of multiplicity, what we're going to do is we're going to revisit example number 3. Actually, this solution should read minus 2. So if looking here, we can clearly see that -2 occurs an even amount of times, and +2 occurs an odd number of times. When I'm actually graphing it, I'm only going to graph them one time, but it affects what happens to our graph at those points. So let's go ahead and make note that at 2, 0, the solution only occurs once. Therefore, that's odd multiplicity. That means what we're going to do is we're going to cross when we're graphing that particular point, or that x-intercept. The point -2, 0 occurs an even amount of times. So -2, -2. We had that twice as far as the solutions go. So what that means is that's even multiplicity. So I'm gonna make a little note of that's even multiplicity. And that means that we're gonna touch and turn at that point. So we're gonna touch and turn. Okay, let's go back and explore the end behavior of this graph in order to put it all together and graph this example. So the end behavior, we call it EB. Remember, we look at the leading coefficient. Because it's the highest degree we have is odd, the leading coefficient is positive. That means it's going to rise on the right and fall on the left. So rises right and falls left. Now let's put all that together and graph it. So from here, what we're going to do is graph what we just found. I want to graph my intercept, so +-2, my y-intercept. Remember, it's going to fall on the left and rise on the right. So I want to kind of connect these points considering the multiplicity. Remember, at -2 we said it occurs an even amount of time, so when I get to that point I'm going to touch and turn. So I'm going to start here, cross the y, and then here, because 2 occurs an odd amount of times, you're going to cross. So let's go ahead and create that. So here, here, and that's how you graph that. Okay, so I was just asked what happens with the multiplicity. How is that affecting this particular graph? So one more time, multiplicity, that means when I'm finding the zeros, when I go over here and I say find the zeros of this polynomial function, and remember we do that for this particular one, we factored by grouping. However many times we get a solution. So if I'm just going to make something up here on the side so you understand what I mean. So let's say I have a new polynomial function and I have x minus 2 squared x minus 4 cubed equals 0. So let's say I factored and that's what I ended up with. So here we got x equals 2 as one of the solutions, but I know that happened an even number of times. Because it happened an even number of times, that has even multiplicity, and even multiplicity means we have that solution 2 times. So how many times do you have that solution is what multiplicity means. So it's there squared. Okay, so if it helps you, break it out. So that's x minus 2 times x minus 2. How many times the solution x equals 2 occurs? 2 times. So the multiplicity is even multiplicity. What behavior does that occur on the graph? That means when you're graphing it, what you're going to do is you're going to touch and turn from that point. Your next solution, x equals 4, occurs 3 times, so that's odd multiplicity. That solution is there an odd number of times. And when you graph it, what that creates is a crossing behavior. You cross through that point. So you're going to cross at that intercept. Does that make sense? Okay. Something else that we want to keep in mind is max number of turning points that we could have for a polynomial function. And it's possible that you could have less than that. However, sometimes, typically it just caps here at what I have written on this slide. If a function is a polynomial function of degree n, then the graph has at most n minus 1 turning points, n being the degree of the polynomial. So if we look at what I have here on this diagram, I have x to the 5th power is the degree. Do you guys see that? So 5 is the degree, so what's 5 minus 1? 4. 4 should be the max number of turning points that I see on this polynomial, and it is. Here's 1 turning point, 2, 3, 4. So I have 4 turning points, and that's the max for this polynomial function. Okay, so now let's take a look at this example and put it all together. This example, it says find the zeros and determine the multiplicity of each 0 and determine the maximum number of turning points, and use a graphing utility to verify. So check your answers when you're done. Alright, so here's the function. We're going to begin, I like to begin with the end behavior. I want to use the leading coefficient test to determine what is going on the ends of this graph and the ends of this polynomial function. Well, because it's the degree of this polynomial is even, it's going to, at the end, it's going to function like a parabola. Because it's positive, that means it's rising to the right and to the left. Okay, the next thing I want to do is I want to find the zeros, or the x-intercept solutions, whatever you want to call it. So I'm going to set x to the 4th minus x cubed minus 30x squared equal to 0. Here I can factor out an x squared. And then I get x squared minus x minus 30 equals 0. Now that I have that, is that trinomial factorable? Yes. What is it factorable to? Good. So x minus 6 times x plus 5 equals 0. So here I get x squared equals 0. Here I get x minus 6 equals 0. And here I get x, that should say plus 5 equals 0. So here x equals 0, x equals 6, x equals negative 5. So what is the multiplicity at 0? How many times did I have that solution? Look here, be careful. It's even. I had it there 2 times because of this. So this is even multiplicity. That means that we're going to touch and turn. These other two have odd multiplicity. They only occur there once. So these have odd multiplicity, and that means we cross at those particular points. The next thing I want to do is find any y-intercepts to help me out, but when I substitute 0 in for x, I notice that I get 0 for y, which we already obtained here. So just write that little step in so that way you don't forget that the third thing you want to do is find the y-intercept. But here again it's going to be 0, 0. The next thing you want to do is you want to check for symmetry to see, does this have origin symmetry, does this have y-axis symmetry. This one, let's take a look at it, no symmetry. So it's not really going to help us. So this one's no symmetry. And the last thing we're going to do is we're going to put it all together. We're going to graph it. Okay? Alright, so let's put it all together. For our intercepts, we ended up with -5, 0, and 6. I know there's no symmetry, so I'm going to kind of make it a little disproportionate. I know it's rising on the left and on the right. And the only one I'm going to touch and turn at is this one. Here, I'm going to cross, touch, turn, and cross. So watch. And then the next thing you want to do is you want to check yourself using a graphing calculator. Notice that I did not use any symmetry because remember one of the things said there's no symmetry to this when I recapped on step 4. To find the zeros on your graphing calculator after you have the graph, hit second trace, and then you're going to have to go left bound, right bound, and you can find the zeros on your graphing calculator. So make sure you practice that. Alright, so this strategy, I kind of already implied it when we were doing the previous exercise. Remember, the first thing you want to do is determine the end behavior of the polynomial. Find your x-intercepts. Find any y-intercepts. Then determine if there's symmetry to help in creating that graph. So in the previous exercise, I determined there was no symmetry, so that's why I made it a little disproportionate. And then always look at the max number of turning points to make sure you're on the right track. So let's put all of this together in my next. Alright, so in this example, it says graph, and that should read x to the 4th power minus 4x squared. So let's go ahead and start that. Again, I always like to look at the end behavior first. So x to the 4th power, it's positive, it's even, so the end behavior, good, it's going to rise on the right and rise on the left. The next thing I want to do is I want to find my zeros. So second thing is zeros. So remember that was x to the 4th. So x to the 4th minus 4x squared equals 0. Here I can factor out an x squared. I get x squared minus 4 equals 0. Break it up. You get x squared equals 4. X squared equals 0. X squared equals 4. So x equals 0 and x equals plus minus 2. Here you can clearly see x equals 0 has even multiplicity. So because it occurs 2 times, so even mult. Let's just write it out. Even multiplicity, so that means you're going to touch turn. Here, this is odd multiplicity. Both 2 and negative 2 occur 1 time, so that's odd multiplicity. And what does that mean? That means that you're going to cross when you graph those particular points. What is the maximum number of turning points for this one? 3. So, and what are your y-intercepts here? Okay, it's going to repeat right here, right? X equals 0, that is your y-intercept. So your y-intercept is 0, 0. Your max turning points, so it's turning points. You take your degree, n minus 1. So 4 minus 1 is 3. So your max number of turning points is 3. Does this have symmetry? If I put in a negative in for x, does it change the function? No. That's y-axis symmetry. So this one has y-axis symmetry. So I'm going to make the left look like the right when I'm graphing it. Okay, so that's what's going to help us out when we're graphing it. So now let's put it all together. Let's graph it. Okay, so now we're graphing it. We're going to go, our intercepts were -2, 0, 2. Remember there's symmetry. So I'm just going to estimate like that my dips occur here. Remember we're rising on the left and right. And that's what our graph should look like. I approximated these points. I don't necessarily know that it's here just yet. I can use my graphing calculator to find those dips. I also want to point out that our multiplicity, remember that at -2 and +2, they were odd multiplicity, so that means we cross them. 0 was there twice, even multiplicity, so we touch turn. Okay, so let's take a look at example number 5. This should read x cubed minus 9x squared. So we're going to graph it using what we've learned in this section. So I'm going to break down those steps again. So let's take a look at step number 1. Okay. We're going to determine the end behavior. What is the end behavior for this function? It's odd. It's the leading coefficient is positive. So what does that mean as far as your end behavior goes? Rises right, falls left, right? The second thing I want to do is find my zeros. And the given, again, was x cubed minus 9x squared, and we're setting that equal to 0. Here I can factor out an x squared, and then I get x minus 9 equals 0. So I get x squared equals 0, and then I get x minus 9 equals 0. Here x equals 0, here x equals 9. So x equals 0 occurs 2 times, so that's even multiplicity. So again, that means we're going to touch and we're going to turn. For x equals 9, that occurs once. That's odd multiplicity. That means we're going to cross through that point. The next thing I want to do is determine any y-intercepts. When I let x equal 0, I get 0 for y. The next thing I want to do is determine the max number of turning points. So that's n minus 1. The degree is 3, so 3 minus 1 is 2. So the max number of turning points is 2. Does this have symmetry? No, it doesn't. Okay, if I put in a negative in for x, it does change your function. If you put in a negative x and negative in for y at the same time, it does change your function. So here you have no symmetry. And the next thing you want to do is just graph it. So let's put it together on our graph. Okay, so now we're going to put it together. We're going to graph it. Our intercepts were 0 and 9. Remember, no symmetry. At 0, it occurred an even amount of times. So I'm just going to go here, touch turn, and pick up here. I'm estimating this point. I don't necessarily know that it's occurring right here. I just know there's no symmetry, so when I graph it, I'm not making it symmetrical.